Graphing absolute value functions, day one. Recall the absolute value is the distance from 0 on a number line. So the absolute value of 4 we know is 4. The absolute value of negative 4 is 4. Here the negative's on the outside, so this is negative 4. And same thing here with the negative on the outside, that means this would be negative 4. So let's go ahead and graph the parent function for the absolute value. So y equals the absolute value of x. We're going to go ahead and plug in these x values in for x into the equation. So the absolute value of negative 3 is 3. 1, 2, 0, 1, 2, 3. So if we go ahead and graph this, we have 0, 0. We have 1, 1, 2, 2, 3, 3. And on the other side, negative 1, 1, negative 2, 2, negative 3, 3. And then, of course, you want to use your ruler when graphing. And I always try to go the whole length of the graph paper. So now we have our absolute value graph. So we can see that it is symmetric about the vertex. And the vertex we can see here is at 0, 0. The vertex is the lowest point on the graph. Everything else is higher. So since it's the lowest y value, that's called a minimum value. For your domain and range, we're going to use our interval notation. So remember, you always go from least to greatest. So the domain goes this way. And in this case, we have an arrow on both ends. So that means the domain is negative infinity to infinity, which is all real numbers. And remember, the range starts from the bottom up. So the lowest value here, in this case, going this way. So this is the range. And so the range starts at 0, and we're including 0, so bracket 0 to infinity. And that's our parent graph. The graph of the absolute value is, of course, we just can see here in our graph, V shape. So it points upward or downwards. And a translation is a shift of the graph horizontally or vertically or both. And the result is a graph the same size and shape, but just a different location. So for this next part, we're going to investigate translations by graphing each function below in the same graph using different colors. So why don't you go ahead and pause the video and do the graphic investigation on your own. When you're finished, you can unpause and check your answers. So for the first one, we just did that. That is our parent graph. So we can go ahead and graph that. So we have our parent graph. And then we're going to go ahead and look at the next one. So if it helps you to make a table, you can. So for the next one, if I were to plug in 0, 0 plus 4 would give me 4, and the absolute value of 4 is 4. So we have the point 0, 4. If I plug in 1, the absolute value of 1 plus 4, so 1 plus 4 is 5. So we have 1, 5. If I do on the other side, negative 1, negative 1 plus 4 is 3. The absolute value of 3 is 3. So notice that that did not go up to 5 here. So that means that 0, 4 is not our vertex because again, it has to make a V shape. And so since this point went down, we know that this cannot be the vertex. If it would have been here at negative 1, 5, then it would have been the vertex. So then we want to keep going. So let's do maybe negative 2. So negative 2 plus 4 gives me 2. The absolute value of that is 2. Again, it still did not go back up. And so let's go ahead and try positive 2. So 4 plus 2 gives me 6, and the absolute value of that is 6. So again, that's going this way, so that still did not give me a vertex. So let's go ahead and do negative 3. Negative 3 plus 4 gives me 1. Let's do negative 4. Negative 4 plus 4 is 0, and the absolute value of that is 0. Let's try negative 5. Negative 5 plus 4 is 1, or negative 1, and the absolute value of that is 1. So now we can see it's going to start making that V shape. So that means that 0, negative 4, or excuse me, negative 4, 0 is our vertex. And we can go ahead and use our ruler to graph the line. And that makes our second graph. And so then we can go ahead and start graphing the last graph, which is the absolute value of x minus 3. So again, we can make an x and y table. So for this, I'm going to plug in, let's start with 0 again. So 0 minus 3 is negative 3. The absolute value of that is 3. So we have 0, 1, 2, 3. If I plug in 1, 1 minus 3 is negative 2. The absolute value of that is 2. If I plug in 2, 2 minus 3, negative 2 minus 3 is negative 1. The absolute value of that is 1. If I plug in 3, 3 minus 3 is 0. The absolute value of that is 0. If I plug in negative 1 minus 3 would give me negative 4. The absolute value of that is 4. So we didn't make our V shape. So I'm going to go to the right of the 3 and do 4. 4 minus 3 is 1. The absolute value of that is 1. So now we're going back up. So that means that at this point right here, 3, 0, that is our vertex. And we can go ahead and use our ruler to graph the V shape. So now we have our graph. Let's go ahead and look at the conclusion. So when y equals x minus h, the graph shifts how? So that would be the x minus 3. So that's the graph in green. Notice that from the parent graph, which is the graph in blue, it shifted the vertex to the right 3. So that means it's going to shift it right h units. And when it was plus h, in this case plus the 4, notice the vertex moved to the left 4. So this goes left h units. So that, if in case you're wondering, means that for this first one, the h is actually equal to negative 4, and here the h is equal to 3. So that makes sense that this one moves it to the right and this one moves it to the left, because in order to get that plus, you had to plug in a negative value. So really, if you think about it like this, y equals the absolute value of x minus negative 4, close absolute value bars. So the negative negative gives you the positive, and that's why you're actually moving to the left. So this is a horizontal translation because we're moving it left and or right. So this is kind of similar if you think about when you did quadratics last year. So remember you talked about quadratic equation and we had the vertex form, x minus 3 quantity squared plus 4. Let's say we had something like this. So remember that this was your h value and this was your k value. So minus, remember, moves it to the right, and this would move it up or down. So this is kind of, like I said, the same idea as when we graphed our quadratic functions. So go ahead and do investigation number 2 on your own. When you're finished, you can pause the video and check your work. So we already did the first one. We have our parent graph we know is at vertex at 0, 0. So we can go ahead and graph that one. And if we look at the next one, we are going to graph the absolute value of x plus 3. Now notice this is different from what we did before because that 3 is not on the inside the absolute value bars. Now it's on the outside. So if we want to go ahead and make a table for x and y, I'm going to start with 0, the absolute value of 0, 0, and then plus 3, so 0, 3. If I do 1, absolute value of 1 is 1, plus 3 is 4. If I do 2, that would give me, the absolute value of 2 is 2 plus 3, gives me 5. So let's go ahead and do negative 1. The absolute value of negative 1 is 1 plus 3 is 4. And notice that is making your V shape now, so I know the next one should go up. So if I do negative 2, that would give me 2 plus 3, which is 5. And then you can go ahead and use your ruler to graph. And then let's go ahead and look at the vertex. So the vertex now is at 0, 3. And if we do the next one, we can again make another table. So for this one, we'll start with 0. The absolute value of 0 is 0 minus 4, so negative 4. If I do 1, that would give me negative 3. If I do 2, that would give me negative 2. And if I plug in negative 1, the absolute value of negative 1 is 1 minus 4, gives me negative 3. And negative 2, the absolute value of that is 2 minus 4, gives me negative 2. And we can see we're making that V shape, so then I can get my ruler and go ahead and graph. And now you can see that the vertex is at 0, negative 4. So when the values on the outside, notice the graph shifted up or down versus when we had our graph over here, when it was on the inside the absolute value bars, we were shifting left or right. So for these graphs here, when the absolute value of the function has the k on the outside, the number on the outside, we're going to shift the graph up k units. And when it's on the outside minus, we're going to go down k units. And this is a vertical translation. So let's go ahead and look at the next part. It says in the following absolute value functions, identify the vertical and horizontal translation. So if you want to do that, you want to first identify what the vertex is. So I'm going to make another column here. So for the vertex of each of these. So for the first one, remember on the inside that's attached to the x, that's going to be your x coordinate. On the outside of the absolute value bars is your y coordinate. So if we look here, this would be the h and the k. So our general equation for our absolute value function is y equals the absolute value of x minus h plus k, where the vertex is going to be h comma k. It's very similar to your quadratic functions. So in this case, notice that we have x plus 3, so that means your h value is negative 3, so that means we're moving it to the left. So minus 3, and our k value is negative 6. So that is our vertex, which means this moves left 3 and down 6. So for the next one, we're going to do the same thing. So we want to identify the vertex. This is my h and this is my k. So the vertex here would be 2, 5. So for this one, we're going to move right 2 and up 5. For the next one, here's my h, and if the k is not written, well, what doesn't change the equation when we're adding or subtracting something? 0. So that's your k value. So we have negative 2 comma 0. For our vertex. So this moves to the left 2, and it doesn't move up or down, so none. And the next one, when there's nothing on the inside, this is really x minus 0, or you could say plus 0 minus 2. So the vertex for this one is at 0, negative 2. So the horizontal translation is none for this one, and this moves down 2. So always identify that vertex. That's going to help you answer those kind of questions. Steps for graphing the absolute value functions. We want to identify the vertex and plot the point in the graph. Pick two x values to the right and left of the vertex, and then we're going to put it in the equation and solve for y. And then you're going to plot the points on the graph. So the first thing, again, you always want to do is find the vertex. So here the vertex is at 2, comma 1. So we're going to plot that. Once you have it plotted, you want to pick points to the left and to the right, because when you pick points to the left and the right, that's going to help you find the graph and make sure your vertex is correct, because you want to get that V shape. So to the right of 2 is 3 and 4. So if I plug in 3 into my equation, y is equal to 3 minus 2 plus 1. The absolute value of 3 minus 2, so that gives us 1. The absolute value, that's 1. So 1 plus 1 is equal to 2. So we have the point 3, 2. And if I plug in 4, y equals the absolute value of 4 minus 2 plus 1. 4 minus 2 is 2. The absolute value of that is 2. So 2 plus 1 is 3. And now we need to do the other side, and remember it should make a V shape if we did this correctly. So on the other side, we're going to pick to the left of 2 would be 1 and 0. So if I plug in 1, y equals the absolute value of 1 minus 2 plus 1. So 1 minus 2 is negative 1, and the absolute value of that is 1, so 1 plus 1 is equal to 2. And if I plug in 0, y equals the absolute value of 0 minus 2 plus 1. So this gives us negative 2 inside the absolute value bars. The absolute value of that is 2. 2 plus 1 is equal to 3. So we have 1, oops, 1, 2, and 0, 3. And notice that it made that V shape, so we know that we did this correctly and we found the correct vertex. So then you want to go ahead and use your ruler to connect those points. And always go the full length of your graph paper. And so now we have our absolute value graph. Then we want to go ahead and state the domain and the range. So their domain is all real numbers, negative infinity to infinity. And the range, the lowest value we have is at 1, so bracket 1, and it goes to infinity. So go ahead and try to do the second one on your own, and then when you're finished, you can unpause the video and check your work. So first thing you want to do is find the vertex. So this is your h and this is your k. So negative 2 comma negative 1, because remember it's opposite. Remember our general equation is y equals the absolute value of x minus h plus k. So since that's a plus, that means your h value is negative. So we're going to go ahead and plot that vertex at negative 2, negative 1. Then we make our table and pick points to the left and the right of the vertex. So to the right of the vertex, we have negative 1 and 0. To the left of the vertex, we have negative 3 and negative 4. And you're going to plot those in for x into your original equation and solve. So when you plug those in, you should get 0, 1, 0, and 1. This is 0 and 1, and 0 and 1. And then use your ruler to connect those values. And then we get our absolute value graph shape. So that's our absolute value graph, and our domain we know is all real numbers because we can plug anything in for x. And the range starts at the lowest value of negative 1, so bracket negative 1 to infinity. Okay, let's look at the next one. So let's go ahead and investigate and see what happens when you have a value in front of the absolute value that's being multiplied. So go ahead and pause the video and do this on your own. When you're not done, you can unpause and check your work. So hopefully by now you guys all know what your parent graph looks like. So we can go ahead and graph our parent graph. So this is our absolute value parent graph equation. And you can look at the first graph if you need to for a refresher. So for this now, we're going to go ahead and graph y equals the negative absolute value of x. So what happens if I have a negative in front? That means remember that all your y values are going to be negative. So if you want to go ahead and make a table of values, go ahead and use a different color. I would have 0, 0 still, but when I plug in 1, the absolute value of 1 is 1, but we have the negative on the outside, so negative 1. 2 would be negative 2, negative 1 would be negative 1, and negative 2 would be negative 2. So when you graph this, you can see that instead of opening up, your graph is going to be opening down. So then we can get our ruler and go ahead and connect our points. So in conclusion, if A is negative, then the graph is going to flip down, or we call that a reflection across the x-axis. The vertex is no longer a minimum value. It is a maximum because now it's the highest point on the graph, or the highest y value on the graph. Okay, so let's go ahead and look at the next examples. So here we have, it says the function f of x has a vertex at, so if we look at our graph here, the vertex is at 2, 1, which is a, in this case, Is it a maximum or a minimum value? So this is the lowest point on the graph, so it's a minimum. The domain for this is all real numbers because we can plug anything in for x. The range starts at the lowest y value of 1, so bracket 1 to infinity. And I guess I should have used the blue because it's the graph in blue. So it's okay, so I changed that because we're using this blue graph here. The next one is the red graph because that says g of x next to it. So here we can see the vertex is at -3, 2. So that is the highest point in the graph, so that's a maximum. The domain is all real numbers, which is going to be the case for all absolute value graphs. And the range now, the highest point on the graph starts here, so our values are going up to this point. So we have negative infinity because you always go least to greatest, and the greatest value that you have is at 2, so 2 bracket. Now for these, we could also practice writing the equation for them. So remember that y equals the absolute value of x minus h plus k. So you just need the vertex, which we have. So if I wanted to practice writing the equation for the blue graph, this would be y equals the absolute value of x minus 2 plus 1. And if I wanted to write the equation for the graph in red, the vertex we know is at -3, 2, so y is equal to the absolute value of x minus -3, so plus 3, and then plus 2. So that would give us our equation. So notice that they are V-shaped. Um, they are symmetric about the vertex. So if we're looking down here, this is for the parent graph. So if it's any graph, then it's symmetric about the, I should say, vertex. So if we have the point x, y in the graph, then the point -x comma y exists. And again, this is for y equals the absolute value of x. And the vertex is the highest or lowest point on the graph. And that's it.